Okay, we are going to talk about a linked list. Before we go into linked list, we have to revise certain things. We have seen arrays, right? The arrays are nothing but contiguous memory guaranteed by the compiler and the system where everything is next to each other. All right. But the problem here is if you were to delete certain cells, you really don't want that, right? If you really want to delete this cell, you cannot delete it. All right, you cannot do that at all. There might be some situations where you want to insert something else, right? Let's say you have a sorted list 2, 8, 19, 30, 51, say 71, and you have a new number that is coming in, say 40. You want to insert a 40. It's just not possible. You may have to shift everything, and there's no way you can insert it unless you move things around. But in the case of, that's one disadvantage with arrays. Okay, that's a negative point. With linked list, you will generate a set of memory locations where everything is linked together like a train where each car is linked to the next car. All right, like that, where you can keep 2, 8, 19, you go to the next one, it goes on and on and on. Let's say 30. So if you were to insert, say, 11, all you got to do is simply insert a new one, say 11, and take this point there and remove that pointer, point him to here. That's all. You just have to insert and adjust the links, and you inserted very easily, right? So that's one of the positive things about linked list. But of course, the negative thing about linked list is you got to search sequentially to then go to this link, then go here, and then from here you go here. There is no way you can jump into a particular cell and search for certain things. Whereas in array, you can, if you want have the fourth element, fourth cell, you can simply jump there and get it, where it's not possible in this linked list. So that is something you have to understand. All right, so let's reiterate what we have done. In linked list, the traversing is just not possible efficiently. Okay, in linked list, the negative thing is traversing is sequential. Okay, here it's random access in a way. If you want to, or direct access, you should say direct access. If you want to have the fourth element or second element, you just have to give the index and you get it. Whereas here it's sequential. You need to go one at a time till you reach your target. Whereas it's flexible. positive thing about linked list is flexible. You can insert, you can delete, all right? It's very easy. Whereas here, it is not possible. Once it's given, and you can't insert or delete efficiently here. The other thing before we go into linked list is I want you guys to refresh malloc. All right, malloc is allocate memory. All right, so whenever you say allocate malloc 4 bytes, it allocate 4 bytes for you. And if you want to traverse this by character, you need to point a character pointer to that. All right, then you go 1 byte at a time. If you want to go 4 bytes at a time, then you point integer pointer to it. So this is something you need to refresh your memory and start listening to this video lecture. I will anyway go ahead and give you a brief lecture. And you also have to know about structures. Go ahead and talk about refresh structures, how we did structures, and of course pointers. You have to know pointers. All right, and you should know type def. It's not important right now, but as we go, you'll see how this is important. So go ahead and review arrays malloc. Like I said, malloc is a library call that you would call to allocate memory, and that memory you can traverse the memory using char pointer or integer pointer. It's up to you. You can also traverse using structure pointer, right? And predominantly we'll be doing how to traverse the memory using structure pointer. And go ahead and revise structures and of course pointers, type def. Okay, let's start. So the linked list, like I said, the way to link each and everything is you need to have some data, right? And then link to the next structure. This is the structure now, right? So how many members do we have in this structure? Let's say we have a data. Let's pretend our data is name, a string array, right? A char array, let's say name 16 bytes. So here 16 bytes data here, and we have a pointer pointing to, right now is empty, so that is null. And so we need to, how many members do we have now? 1 and 2, right? 2 members. So our structure, let's define a structure. So what is our problem right now? The problem, I'm going to give you the problem is something every student likes it. We are going to create a linked list of sitcoms. Yes, sitcoms. It's easy to remember that. So sitcoms is the name, like I said, right? So what kind of sitcoms we have? Raymond, we have Seinfeld, we have Big Bang Theory, Big Bang Theory, or Big Bang, whatever. We have Cheers, right? And of course, there's no sitcom without that. What is that? Married with Children. Oh, Married with Children. Sorry. All right. So we are going to create a linked list of sitcoms. We are going to keep it simple, just the name. All right. We can add more names to it, characters. We can add a producer, director, all that. But right now we are just keeping just the name of the sitcom, and the next one it will be pointing to, say, Seinfeld, and the next one it will be pointing to BBT. Okay, and it goes on. Okay, you got the picture. So if you just take one, we are going to just look into one and forget about the rest. Okay, only one we are going to look at it. The first, how do we do this? How do we declare a character name and a pointer, right? Remember, one thing is this pointer actually pointing to that guy, like that. Okay, every pointer, let's say this is next pointer. Okay, it's a pointer. The next pointer always point to the next block memory location. Next. Okay, let's say this address is 4460. This address is something like 5460. This address is 6460. Okay, so when this pointer pointing to this block of memory, which is 54, the starting is 5460, what does it mean? That means it's storing that 5460 here, right? Pointers always store the address of where it's pointing to. And what is this pointing to? 6460. And let's say this is pointing to 7460 somewhere, right? So that is what we are going to do. We are going to define a structure, right, that will represent this block of memory where 16 bytes is for the name and a pointer pointing to the next block of memory. And if you look at each block of memory, what is that? It's a structure, right? So we are going to declare a structure of sitcoms. Remember, go back to your previous thing, right? I'm going to erase these things for now. We don't need this since you guys already know what it is. So character, name, 16. So that is one member. We got one member out, right? One member out. Also remember, these are called self-referential links. Self-reference. They refer to themselves. Okay. So another member is pointing to same kind of memory, right? This memory, the structure memory, whatever you have, and this pointer is pointing to the similar structure, right? When an integer pointer pointing to integer, what does it mean? It's pointing to a 4-byte memory. That's what it is, right? An integer pointer pointing to 4 bytes. Similarly, a pointer pointing to similar kind of structure should be of type this, right? So struct underscore sitcom star next. This is very important. Sitcom, because we are declaring a pointer that is of type this sitcom, right? So this whole thing, all right, represents a one linked list type. We are only declaring a type. Remember, we're not declaring any variable right now. Look at here. There is no variable declaration. We are only declaring struct underscore sitcom, a type of structure that has two members, 1 and 2. One is a character array of 16 bytes to store the names of our sitcoms, and the next one is a pointer of type what? Structure underscore sitcom, and we need to make it as a pointer. So this pointer, next pointer, points to memory location which is of type structure underscore sitcom. See that this pointer pointing to what kind of structure? So this is fundamentally the basics, or sorry, this is the basics of linked list. If you do not understand this, pause the video, go back and revise this again. Okay, let me erase all this and redo a simple one. So we are declaring a structure of type sitcom. This is tag name. Remember the tag name? Sitcoms or sitcom char name 16 byte sitcom, all right, pointer next, all right, all right. So we have returned this, this structure. What, by looking at it, you should know, oh, it's a structure. There's one member, the tag name. Another member is a structure of its own kind. So you should be able to draw, looking at it, character name, which is 16 bytes, sitcom next. Oh, it's a pointer pointing to some other structure, right? So let's go back and define this in a C language and see if it is makes sense for us. Sitcom.c. Okay, like I said, include. I'm writing everything in front of you guys. We're going to use string.h for the thing. So let's define structure underscore sitcoms, right? Character name 60. You want to keep 16 bytes or 32 bits? Let's do 32. Let's say 16. All right. To self-referential. Okay. That's it. If I ever declare a something like this, what does this mean? This means I'm declaring a variable sitcoms, which is a structure having a tag named sitcoms, but I'm not going to declare a variable yet. I don't want a variable because I'm going to allocate memory as we go. Remember, the next sitcom, we don't have it. We don't have it yet. We are not yet to make. Even this is we are yet to make. In fact, this is there is no such memory right now. Remember that there is no memory allocated yet. All right. We are only defining it right now. A structure with a tag name sitcom. I said sitcoms, right? Okay, let's get sitcoms. We are yet to allocate memory right now. All right. Okay. Then main. I'm going to compile this for now, so just to make sure that we are okay. No problems, right? Good job. Let's go. Now, one thing now we are going to create. Let's go back here. Now I'm going to erase it for now. Let me copy that guy to here. So what I'm going to do is allocate memory for this. Okay, allocate memory for. I'm going to write small. Okay, name and a pointer. That's what I'm going to allocate a memory right now. So how would I allocate memory for this? One thing you need to understand is, okay, how would I allocate memory? Do you guys know that? We talked about it, malloc, right? Malloc is the function to allocate memory. But how much bytes you want to allocate for this guy? How much memory is this for this guy? Is size of what? Struct underscore sitcoms. So this will give me a memory in space. We are only telling the size of this guy. It could be 16 bytes, it could be 20 bytes, could be 48 bytes, I don't know. A point, this is just a pointer. Pointer is just like any other, it stores address. It has a fixed number of bytes, right? And let's go and print this first, how much it is. Okay, let's go and print it. So print f I'll just put it for now. All right, I'll just convert to integer. So this should tell me how much memory I have allocated. 24 bytes. 16 bytes and 8 bytes for this, for the pointer. Can you guys guess why it is 8 bytes? And this is 16 bytes. So total 24 bytes. So we got that 24 bytes. So we don't need this anymore for now. So every time I do malloc, okay, let me remove all this guy. I don't need any of this guy. So every time I do malloc, that means allocate a memory, okay, allocate a memory of size structure underscore sitcoms. What does it mean? I'm allocating 24 bytes. But remember, whenever I allocate memory 24 bytes, I'm just getting a raw memory. It's a raw memory somewhere in the system, somewhere up in the air, okay, which is 24 bytes, which is 0 to 23 bytes. But I don't have the address of this guy. I need to capture that address, right? The way to do that is, it is somewhere we can capture the address by this, if that's what you want, but we don't want that. We don't want a character pointer pointing it to malloc. Is that what you want? Oh, do you want to point a character pointer? We don't want that. We want structure pointer pointing to that. Okay, a structure pointer. So in order to do that, here we need to point to structure underscore sitcoms pointer. Okay, now I got a pointer, some pointer pointing to that, but I have to store still this pointer somewhere. I got the memory. It's like a character pointer, but I have to store the pointer somewhere. So what do? I do is structure underscore sitcoms. It's always the very first node. Where is it? The very first node that you allocated, it's always the head of the head, just like the engine of a car, of a train, right? So you need to declare a variable called head and point that head over there. This is very important. Just pay attention to it and you will understand what I'm talking about. So let me revise this for you guys again. I got the size of the memory. I'm allocating a memory. All right. Let me erase this. I got a memory somewhere. Okay, I allocated everything, my name and the size, whatever the pointer, this pointer. Next, I got this memory, but now I need to, just like your character pointer or integer pointer, we need to, let's say this is 4460 is the address of it. So I need to declare a pointer of this guy, right? Structure, sitcoms, pointer head. This is a pointer of type this guy. Now I want him point to this 4460, right? For that, malloc, let's say 24 bytes, I already got it. This is a raw memory. I want to point structure, sitcoms, and a star. So this will give me this address, okay, 4460, which I'm assigning it to head pointer. So my head point is also a memory somewhere, is address. So I'm storing 4460. This is the head. So head is storing 4460 through this guy. Just pause this video and just understand how this is done. Okay. Okay. So going back here, now I'm going to erase this again. I have erased the whole thing. So now you have a head, name, next pointer, and we have the head address, sorry, head. Let's say this is 4460. We have stored 4460 in this pointer. So head is, in a way, technically head is pointing to here. Okay. So we want to now store what? In the name Raymond. Is that what we did? We want to know, we want to store Raymond in this structure, in this place. So how do I do that? Head dot, remember we talked about name Raymond. This is a string. So string, you cannot just assign strings to each other. We have to do copy. So that's happened, right? Now when you do it, now Raymond gets copied into head.name. So so now I got Raymond. All right. Now go back. Now I need to have another node called, say, node. Okay. This is a blank node for now. There are two steps we need to do now. Usually when you're building this linked list, right, the engine of the linked list, which is the head, it's always kept pointing to the first node. Then we always use another point variable called node to build the next structure. Okay, this is the name and this is the next point. We have built this guy. This guy is done. This guy is in memory right now. Okay, but this guy is not yet. We need to build it. So we have to point this node pointer point to the same place where the head is pointing to. That means node equal to head. That means wherever head is pointing to, let the node also point to. So node is also pointing there. That means 4460. Node equal to head. Okay. Now build the first node. Now build the second node. Okay. How would I build a second node? First get a pointer, structure, name, and next. How would I get this? Malloc size of the structure, right? We just repeat the same thing again. That's it. Once you know how to do it, the rest is all same. And point structure underscore sitcom pointer. That's it. So repeat the same process here, but keep the node at the same place. Okay. See, now again I got the one bunch of memory. Now I need to store where? Node. Let me tell you how this is done. We have allocated this memory. Let the address is 5460, and we are saying, hey, we got the memory allocated. We are pointing a structure underscore sitcom pointer to that location and store that pointer into 446 into node. That means, oops, 5460. The node is pointing to this guy now. Node is pointing to this guy. So we have two pointers. One guy is pointing here. The node is pointing to here. But look at this guy. He is hanging. And he's hanging. This pointer is supposed to point somewhere, right? Just like an engine in a train. This is a car. This is a car. This is a car. This is a car. We got the first head and the node. Now we need to link these guys, right? That means this, whatever you call, I don't know, the chain that from the rear end of this car should be attached to the front of this guy, right? That means he's a pointer, has to be pointed somewhere. That means we have to store in this pointer address of somebody. We can store 5460 right there. How would I do that? How would I do that? So how do I get to this member? Head dot next, right? Head dot next. Because it's a pointer, we always do that. And we store what? Node. This is again important. How to link? To link nodes. This takes time. I understand you if you're having trouble because it's the first time you guys are watching me doing it. As you watch me several times, you'll understand what I'm doing. Okay. The very important points to note is this one. Very first step one is to allocate memory, right? Allocate memory. Then you allocate pointers or assign pointers. Okay, it's not, it takes time, don't get discouraged by too many pointers and too many uh, things. Linked list is the one of the critical things in C language. Okay, so let's go back here. Okay, so we have so that means we have assigned this guy to here now, right? The node is still pointing here. The node is still, we didn't touch this pointers now. Remember that. Because we have only took the node address, whatever node is 5460, we have assigned it to the head.next, right? Yeah. Okay, so we have this. So we got all this now. We got this, and see that head is still 4460, is still watching the beginning of this block. Head.next is linked to 5460, which is this block. This guy is still pointing to empty, up in the air, right? And how do we access this guy? Node.next, right? Okay. And we need to copy this guy. This guy's name is still empty. So we need to go there and copy, like we did string copy. But this time it's not, no, it's node.next. Dot name, sorry. But it's not Raymond, it's Seinfeld, right? Yeah, see this here, node.next is Seinfeld. Node.name, sorry, node.name is Seinfeld. That's what we are doing it. All right. So we got that. We got two nodes now. Now build the third node. Same process, but you got to uh, jiggle or juggle the node pointers, then you'll be able to get it. We are not done yet. Okay. Now look at couple of observations you need to know. Okay, this 5460, who are all watching it now? Can you tell me how many variables have this address 5460? One is node, the other is head dot next, right? So you don't need two people watch having the same thing. That's one observation you need to understand. Two people or what, two addresses storing the value, the address of the second block. Okay, remember that. That's very important. Now let's go back and create our third node. We don't need this guy also. Okay, okay. Now create a node. How would you create the node? Go back here. I got a memory again, malloc size of blah blah blah, pointing to by a pointer, but we need to assign it to somewhere else. We don't know that. We got the memory, we allocated the memory right now using this statement, right? But now before, okay, now I have to assign this node here. I don't need this guy here because my head is anywhere here. Or what I can do is, I know node dot next is pointing to nothing. I can divert that guy back to here. Yeah, I can do that. So I got this memory. How do I point node dot next here? Very simple, right? All I got to do is next. I got that. See that? Did you guys see it? Now this memory, let's say this memory for 6460. I'm storing 6460, which is this, into node.next. That means here, right? 6460. So since you guys are not can visualize, I'm going to point the pointer like this. Okay, so now my node dot next is pointing to here, so I link them here too. The next phase for you should be, you have filled in Seinfeld here, you have filled in 6460 here, so these two nodes are filled up, these two nodes are not filled up. So we can now this node pointer can move here, right? Can we or can we not? So let me move that guy here. How would I do that? How would I move? How would I move the node from here to here? Let's rewind this again a little bit. Right now my node is here. I want this node, which are pointing to 5460, should be 6460 here now. Okay, that's what it means, right? I want it to be 6460. How do I do that? See, a node dot next is what? Has the 6460. So node, it's a pointer, has 6460, assign it to node, right? So that becomes 6460. So I need to do this equation right here. Okay, so I now I pointed my node in here. This is no more pointing here. This is pointing here now. You see how the node was slowly moved from here to back here. Now we are not filled up these two elements. How would I do that? See here, node dot name to Raymond Seinfeld. What else we got? Big Bang Theory. All right, Big Bang Theory, and this is pointing to nothing, right? It's right now nothing. I'm going to erase this guy. Okay, so we got four things, right? We got again build the fourth node. How would I build the fourth node? We know how to structure underscore sitcoms pointer. We know this memory. And pointing to what? Node, same thing. Is not, there is no rocket science. So we got one more memory here. Okay, same what I did here, I got here. I got a memory now. This is the fourth node. And where would I point this guy? Node dot next is empty, so I need to watch pointing to this guy. How would I do that? This is what this node. Oh, this is the fourth node. Sorry. So node dot next we got. Let's say this memory is 7460. I allocated the memory. I'm assigning node dot next to that memory. That means this is 7460. All right. And the node has to be moved here now, right? How would I move that? The way you did before. Move that guy to here node. That means this guy changes now. It's not 64 anymore. This is 7460. See how I'm changing the memory locations? Okay. Then my node is pointing here, but this is empty. I want to copy something, right? A sitcom. What did we do? We said the node copies married with children, married with children. Yeah, that is how it's done. MVC. This pointer is now pointing to nothing. So at any moment, if you see the node, you need to have a pointer pointing to where you are going to add. In this case, this is the end, and my head is never changes. You see that? If by any chance, if you change this value, you lost your head right now. You lost your chain. In other words, if you ever lose the engine of a car, of a train, you lost the train. So you have to make sure the head is always pointing to the first element, always 4460. Okay? So try to revise this and understand this code. Okay, let's compile it. We are not compiled it. So for a lot of problems. Here, if you look at it, node is undeclared. Let's fix certain things. Node does not. Okay, and should be working. Let's clear it. Okay, we have more errors right now. That is good. Okay, 18. Okay, here. Uh, string.copy. We need to okay, we need to include that. And we have, oh, see here, this is a problem. See here, sitcom, yes, sitcoms and sitcom. That is the problem why we are getting all these errors. Okay, this is again problem here. Oh, I copied the same thing again. Oops. Okay, we now compile it. So that is the first lecture on linked list. It gets some more things we need to do is uh, print it. Okay, print the values to make sure that they are really printing. The last node I made null. Okay, the last node I made null, pointing to null. So we are now going to traverse from the head, each and every node. We're going to print each and every one of them. Okay, like I said, linked list is all about traversing sequentially, right? So to print all nodes, we need to keep the head, and the head is should not be touched. Okay, so let's declare a new variable that points to the head. Okay, let's keep it as a print node, or let's keep it as very simple as p node. Okay, or current node, maybe current node. Okay, c node is current node. Okay, so we will keep head should not be touched, so we see node equal to head. So now there's a new pointer called c node pointing to head, right? C node. That means whichever head has address, create, this is a C node. When C node C node equal to head means whatever the value here, put it here too. In effect, point to that memory location. Now, while we are going to print each one of them, right? Very simple it is. How would I, is C node dot next, C node next, is it null? Now what we are trying to do is we are going to move this pointer from this pointer to here to here to here until it sees a null. Okay, then we stop. So what we are going to do is while C node dot next or C node dot next is not equal to null, right? That's what we are going to do. It's not equal to null. We are going to print f the node, the sitcom name is what? C node dot name, right? So look at this two statement. While c dot next is not equal to null, while c node dot next is not equal to null, in this case is not equal to null, it's 5460. So print c node dot Raymond. That's what I'm doing. Okay. Once I print this guy, right, I need to move my C node to here. How would I do that? I'm done printing. Now I would say C node equal dot next, right? wherever C node dot next is pointing to, which is 5460, make it the value for C node 5460, right? That's what I'm doing here. So we're done. So what happens is it comes here, C dot next is not equal to null, it prints it, then go back here, it prints this guy, it'll come here, it C dot node is null, so it won't print this guy, so we need to make attempt to print it. So when outside this loop here, we need to print that guy one more time. Okay, let's pretend we don't print it. We'll see how it is. Okay, there's no compilation errors. If you see it, we are able to print Raymond, Seinfeld, Big Bang Theory, but we couldn't print Married with Children. The reason because we came here, our C node was pointing here, and we say while C node dot next is not equal to null. In this case, is equal to null, so you didn't print this guy. So outside the loop, when you have to come and print it. Now when I do it, it is a long lecture, and it is one of the important concepts in C language. That's why I'm spending a lot of time with you guys. Here, if you see it, Raymond, Seinfeld, everything I printed. So this is how you navigate a linked list to insert and to print. All right. That is how you, now if you see it, our C node is pointing here at the end. All right. And our head node is still pointing untouched. All right. So we have been able to traverse the list.